Okay, this is going to be an explanation of the decoder modules. So a decoder is a module that takes, some number of inputs and uses that to drive two to that number outputs, right? So for example, so a decoder has n inputs and it drives 2 to the n outputs. So to start, we can look at a 1 to 2 decoder. And so this is a module, and it is typically drawn like this, right? With one input, which I'll just call in. Well, it actually has another input called enable, right? So it does have an enable selector, and it drives 2 outputs. So I'm going to call this out 0, and I'm going to call this one out 1. Okay? And basically, so see how these outputs are numbered 0 to 1, and how this is an n-bit input, or in this case it's a 1-bit input. Basically, whatever binary encoding like this input is representing, that output is going to be high, and all the other ones are going to be low, right? So if in is 1, then out 1 is going to be high, and out 0 is going to be low. And if enable is disabled, right? So if enable is low, then all the outputs are going to be low, right? So what does this look like in our truth table? Well, we have 2 inputs, right? We have enable, and we have in, right? That's on our input side of our truth table. And on our output side, we have out 1, and we have out 2, right? Now, let's fill in our truth table. So 0, 0, 0, 1, 1, 0, 1, 1, right? And so, remember what I said, if enable is low, all the outputs are going to be zeros, right? And if enable is 1, then we're going to do the decoder thing, right? So, in is 0, right? Which means that that's out 0. I lied earlier, that's out 0, right? So if in is 0, then out 0 is going to be 1, and out 1 is going to be 0, and vice versa, right? So how do we go about building a circuit? Well, what you're going to do is write this as sum of products for each of your outputs. So let's start with out 0. So how do we do out 0? Well, out 0 is true whenever enable is true and in is false, right? And so we have enable, right? Enable and not in, right? Because that is when out 0. It is true if and only if enable and not in. And what about out 1? Well, out 1 is equal to enable and in, right? And so our circuit, right, if I can draw an AND gate, not an OR gate, right? I'm going to draw that here, right? A circuit is going to look like this. So here's enable, and here's in, and actually we're going to have that one be not in, so we're going to bubble it, right? That is out 0. And then if we were to say enable and in, right? So enable and in, that is out 1. So let's implement this in HDL, hardware description, right, language. So we have our template Verilog file, right? And what we're going to do is we're going to implement that. So the one thing that I'm going to point out is that instead of having 2 outputs, it is 1 output as a bus, right? So it's a 2-bit bus that we are outputting. And so what this template starter stub is telling you is that it's just basically, it's combining those 2 outputs to be a 2-bit bus called out, right? And you have enable still, and you have in as well still, right? But just keep in mind, it's a bus, and so we can index each bit of the bus, so this would give us the most significant bit, and that would give us the least significant bit. Okay, cool, right? So for our decoder, we can say always com begin, right, end, and what are we going to do? Well, let's look at our truth table, but not our truth table. I meant to say, let's look at our sum of products. So let's start with out 0, right? So we can say out 0, right, because that's going to be our least significant bit of our output, and that's equal to, what is it equal to? Well, we go back here, enable and not in. And so in Verilog, we say enable and not in. What about out 1? Out, I can't type today. Out 1 is equal to enable and in. And there you have it. And if we go to our shell, right, so we have a shell. If I was to run make test decoders, right? And I forgot that this is a very big output. So if we look at this, this is a selector bit, right? This test is also testing, the bigger decoders as well. It goes all the way up to a 5 to 32. But in this case, it just takes, for the 1 to 2 decoder, what it's doing is it's looking at this bit, right? And it's selecting, and on the output, which is written in hex instead of binary for some reason, well, it's so that way the big one works. It's going, 1 2 1 2, which is equivalent to 0 1 1 0 0 1 1 0, which it's alternating between these two. And so we can see that it is in fact working. And then when enable is disabled, so it's not enabled, you can see it's all zeros. So that is good, right? Now, what about a 2 to 4 decoder, right? 2 to 4 decoder. So we have 2 to 4, right? Well, what does this look like? Well, it's going to have a 2-bit input in, right? It's going to have an enable input, and it's going to have a 4-bit output, right? And what we're just going to say in our truth table is we're going to have, enable in, right? And I'm just going to say 0, and then don't care, right? And then what we're going to have as well is on our output, we're going to just have out, and then that's a 4-bit output, right? So that's going to be 0 0 0 0, and then when it is enabled, right, have 0 0 0 1 1 0, and then 1 1, right? And all of these are enabled. And so what we're going to do is it's the same thing where this in binary, well, this binary value represents the number 0. So the 0th output is going to be high and all the others are going to be low. This represents 1, right? Because 0 plus 1, or 0 times 2 plus 1 times 1 is equal to 1. So the 1th output is going to be, and then this represents 2. So you can see this one's going to be out here, right? And then what about this one? That represents 3, and so there you go, right? Makes sense. That is what our truth table looks like. Now, we can go about again doing the whole thing again. If we can say, oh, out 0 is equal to enable and then you can say, oh, enable and you can say, oh, enable and in 0, like not in 0 and not in 1. I'm so sorry, I'm like mixing my Verilog and Boolean logic symbols and such. That's fine. You can do that, but you can imagine if you're gonna, and you're only doing this for 4, and so that's fine. But eventually you're gonna be making like a 5 to 32 decoder, right? And you can imagine that you're not gonna want to go about your sum of products for that. So is there a way we can do this using modules we already have? And the answer is yes. So if we want to, instead of doing that truth table, if we wanted to, make a 2 to 4 decoder, we can use 1 to 2 decoders. Well, how do we do that, right? Well, let's say we have a decoder, and let's say we have 2 more decoders, right? So here are 1 to 2 decoders. And what we can do is, here's enable, right? And here we have S1. And so S1, because if you remember our truth table from up here, right? You can look at this. If you look at the 2 least significant bits of out, right? You can see that these 2 are on when this is 0, and then in 1, right? In 1, it controls these 2. I called it S. I meant to call it N. Do forgive me, right? So in 1, right? And what we can actually do is, if we use the outputs of this decoder, we can control whether or not these ones are enabled, right? And then here are outputs, right? And then this is in 0, right? Then in 0, right? And I hope you can see how, if this is out 0, out 1, out 2, and out 3. I hope you can see, for example, right, how let's just walk through this, right? So let's say in enable is true, right? And enable is 1 and input is 0, 0, right? So if enable is 1, this decoder is on, right? And in 1 is 0, and so that means this output is high and this output is low, which means this decoder is disabled, so these are going to be zeros. This decoder is enabled, and then in 0, you can see how if in 0 is controlling it, if in 0 is 0, then out 0 is going to be 1, and out 1 is going to be 0. And you can convince yourself that, right? So I'm so sorry, I just hit my mic. How do we do this in HDL? This is a great way to explain to you how do you instantiate modules inside of modules. So if we do decoder 2 to 4 SV, right? And we were to say make it bigger, right? So decoder 2 to 4 SV, right? Well, instead of doing an always com and implementing our truth table, what we do is we're going to instantiate some modules. And so the first thing that I should make clear is that I did not draw a black box around this, right? But within a black box, right? Within a black box, right? Into the black box we have in and enable, and coming out, we have out, right? And inside of here, there are 3 decoders, right? And if you look at that, there are 2 wires that are not from, I just drew this backwards. That is really funny. If you look at this, right, there are 2 wires that are not actually interfaces to the black box, and that are these 2 wires. So I'm just going to call this internal wires, right? And so that's internal wires 0 and internal wires 1, right? So what we can do is in Verilog, right, you define the inputs and outputs of the black box, when you say input and output, right? But you can also create wires that don't exist inside the black box but aren't part of the interface, right? So we can say wire, and it's going to be we need two of them, so we're just going to have, and we're going to call it internal wires, right? So we're going to have internal wires, and it is it's a bus or two wires. And what we can do is we can now say, okay, what if instead of doing that truth table, we said we use a decoder 1 to 2. Okay, so decoder 1 to 2, and when you look at decoders 1 to 2, right, you have your inputs, and so dot enable. What if I actually was just okay, that didn't work. Okay, fine. Is it called decoder 1 to 2? Yeah, decoder 1 to 2, right? So decoder 1 to 2, and you have to give it a name. So I'm going to call this I'm just going to call this decoder A, right? So decoder A, and what about decoder A? So decoder A is going to have similar inputs, right? So it's going to have dot enable, it's going to have dot in, right? And it's going to have dot out, right? And what is going into these inputs, right? Well, if we look at decoder A, so here's decoder A, right? Enable, its enable pin is being connected to the input enable in this. So enable goes to enable. What about the input of this decoder? Well, that's in 1 in our case, right? So we can say in 1. And what are we outputting to? We're outputting to internal wires 0, right? So we can say internal wires 0, right? Make sense? All right, we good. And we now have, decoder B and decoder C. And these have different things going into them, right? They have different things going into them. So if we look at it, right, what is going into the enable of decoder B? Well, here's its enable. Well, that's internal wires 0, right? So, oh, that's not what I meant. Not internal wires 0. The out is just internal wires because it's a bus, because that's internal wires 0, internal wires 1, right? So the input to this one is internal wires 0, and the input to this one is internal wires 1, right? You can see how internal wire 0 is going to this decoder's enable, internal wires 1 is going to that decoder's enable, right? What about its input? Well, remember they both have in 0 going to there, so in 0 and in 0. And what about their outputs? Well, this is going to be out 0 and out 1, right? So out 1 colon 0, and this one is going to be out 3 colon 2, right? And there we go. And if we go to our happy little shell and we run make test decoders, right, we can now see that the outputs as you look at it, right, so it's going to be going, we're looking at these 2 bits, right, these 2 bits, right, and so the outputs in binary, if it's following this truth table, which is going to go 1 2 4 8 1 2 4 8, if we look at it, this output should be 1, and you can see it's 1, right? Then go 0 1, right? So 0 1 2 1 0 4 1 1 8, and look at that, it is working. Now what I'm going to do is I'm going to have you ponder this. How could you use, right, how to use 1 to 2 and 2 to 4 decoders, right, to make a 3 to 8 decoder, right? And for the remaining decoders, I'm going to let you figure that out. I hope this video was helpful.